Hi, my name is Alon Erev. Today I'll present our work Cross-document Event Coreference, Task, Dataset and Modeling. I'll start with a short introduction of what Cross-document Event Coreference is. To illustrate, we have here two different articles describing earthquake events. In the Cross-document Event Coreference task, we would like to identify whether different events mentioned in text co-refer to each other. This means that those event mentions refer to the same real-world event. For example, if we examine the earthquake event in those articles, we would like to know whether they refer to the same earthquake event. This can be determined by looking at the surrounding context. For example, the events share the same date, the same location, and seems to have affected the same community. We can therefore assume with high probability that those event mentions indeed co-refer. Cross-document event coreference is considered an important task in information processing. For example, we can consolidate information about an event which is mentioned in different contexts, as illustrated in this example. Currently, the cross-document event coreference task is formulated as identifying all coreference relations across the entire document set. A typical cross-document event coreference model receives as input a document set. It will then resolve all coreference links between all the events mentioned in the texts, and finally output the coreferring event clusters. However, a realistic scenario may be that given an event of interest, we would like to efficiently search all coreferring event mentions only to this specific event of interest. This can be applied for cases where we would like to find more information on a particular event. For example, the earthquake event from the previous slides. We might like to explore accommodating information about it provided in different documents where it was mentioned. Accordingly, in this work, we would like to set the coreference search task as a well-defined task for research. To that end, we propose a new task definition, dataset, and model. We formulate the task, so an instance of a coreference search will be composed of two inputs, a query containing a target event mention in context and a large collection of passages to search in. The output should be all passages containing an event mention coreferring with the query event. To form a dataset for our coreference search task, we would like to have many instances for train development and test sets. Therefore, we created the core search dataset, including two separate passage collections, a collection of passages containing manually annotated coreferring event mentions, and the second collection of many non-annotated passages which are unlikely to corefer with any of the annotated passages. To derive an instance from our core search dataset, we will consider the input to be a query pulled from the annotated collection, and all other passages, both the annotated and non-annotated ones, as the passage collection to search in. The output should be all event mentions within their passages that belong to the same coreference event cluster as the pulled query. We would like to use existing cross-document event coreference datasets. However, existing datasets are relatively small for a realistic search scenario. We therefore leverage a previous work of ours published at NACL 2021, the Wikipedia Event Coreference Dataset. The Wikipedia Event Coreference Dataset was collected by clustering Wikipedia links pointing at the same Wikipedia article. This can be illustrated here, where we have two separate Wikipedia articles mentioning the 100-meter event, marked in each one separately. We can say that those events co-refer to each other since they are both referring to the same Wikipedia article, which is the men's 100-meter competition at the 2012 Summer Olympics. The annotated portion of core search was derived from the manually annotated portion of WEC, and we generated the reliable destructor passages using the non-annotated portion of WEC and also heuristically from the English Wikipedia. Overall, our core search dataset provides 3,110 annotated passages, which we use to derive queries from, and a collection of 2,770,000 non-annotated passages used as the passage collection for retrieval. As regarding to modeling the coreference search task, current cross-document event coreference model designed to resolve all coreference links across the entire document set aren't scalable for the search scenario. Motivated at creating a new efficient model for the task, we observe that the event coreference search task formulation resembles the open domain question answering task. In open domain question answering, we have a natural language question, which then is fed into a model which extracts passage candidates highlighted with the most probable answer to the question. Similarly, instead of a question in our task, we have a query, which is a passage containing a highlighted event of interest. The model, analogically to the open domain question answering models, is required to return passage candidates containing a highlighted event mentioned most likely to corefer with the query event. Following this notion, we leverage the dense passage retrieval model, a prominent open domain question answering model, to our setting. The dense passage retrieval model is comprised from two distinct components: a retrieval, responsible for efficiently extracting a subset of passages most likely to contain the answer from the large document collection, and a reader component responsible for re-ranking the retrieved passages and extract the answers from each one of them. Similarly, we would like to adjust the DPR model. So in our setting, the retriever will be responsible for returning from the large collection a subset of passages most likely to contain a coreferring event mentioned with the query event, and the reader component will be responsible for re-ranking the passages and extract the coreferring event mentioned span from each one of them. The original DPR retriever and reader models did not work well in our setting. In order to adjust them to our task, we applied some needed adjustment, which help us obtain good performance. Our adjusted DPR baseline model presents appealing results. The MRR at 10 indicates that a relevant result in most cases will return amongst the top 2 results. The recall at 50 indicates that 76.6 of the relevant results for any given query are returned amongst the top 50, and the exact match and F1 measurement indicates how well the model is in extracting the right event mention span from each passage. We further observe that the DPR reader, which is the DPR reader component, which is designed to match an answer span with a question, is suboptimal for capturing coreference relation between two mentioned span within their passage contexts. This is because the re-ranking method, indicated here as the last method, only considers the CLS token as the representation when it re-ranks. However, we would like the coreference search reader to pay attention to the query and passage mentions and determine the likelihood of them coreferring. We therefore replace the reader re-ranking method with components inspired by the within document coreference model presented by Lee et al. Our new re-ranking method takes into consideration a score produced by calculating the likelihood of the query and passage mentions to corefer. Further details both on this implementation and the DPR adjustments that we did is in our paper. Our integrated model further improved performance in all metrics, making it already useful for an applied settings. And to conclude our contribution in this research, we introduced cross-document coreference search, a challenging task for accurate semantic search for events. To support research in this task, we created the Wikipedia-based core search dataset with a large collection of about 1 million passages to retrieve from each set. And also we provide several efficient baseline models and encourage future research on this promising and applicable task. Our dataset and models are publicly available in those links. For any question, please reach us in our email or Twitter. Thank you very much for listening and goodbye.